Hello and welcome to this week's Power Channel TV. Again, we're going to continue on with our fuel injection program here. This week's codes are P201 and P202, so those are injector faults for both A and B, or cylinders number 1 and 2. So we're going to dive into what is the theory behind what this code is representing and involving our injectors here. Obviously the testing methods, both with our digital voltmeter, as well as another specialty tool here that we haven't debuted before, as well as I'll show you a little bit of insight here on the laptop software. All right, so what we end up getting with, or what we are presented with here, is either a 202 or a 201 code. It's really telling us which cylinder is the problem. And it's all revolving around our fuel injector. So what the code is representing is that the ECM does not recognize that that component is there any longer. Okay, it does not see the resistance of its circuit that it represents. So you either have a disconnect of the wiring in the circuit, or something has failed with the component itself and it's no longer providing enough resistance that satisfies what the computer wants to see to recognize it's there and working. So when you're represented with this particular code, the first things you need to check is make sure that you've got voltage going to your connector. So I'm going to focus on number 1 cylinder over here, and there's a red wire that comes into this. Okay, and then there's also a blue wire with a black stripe on this cylinder. The opposing cylinder has a blue wire with a white stripe. So I'm going to be back probing the red wire here first. Now you're going to want to use the back probe pin with a fuse in it. You are testing 12 volts. If you short this end to ground, you are going to have a problem and let the smoke out. Okay, so you need to use the fusible link here. So what I'm going to do first is I'm going to back probe into the red wire connector here. Okay, hook that up to my red meter lead, and then I'm going to take another one, and I'm going to actually just take my black meter lead straight to battery ground here, and that is good enough. Okay, because how these things work are, when you turn the system on, the red wire is powered with 12 volt all the time. It's hot. Okay, so what I'm going to do is go straight to my ground up here, as well as look at my meter, and I should see battery voltage here. Okay, which I do. I see 12.8 volts. So that is good. So that tells me part of my circuitry is intact. Now I can go ahead and remove the back probe at this point. Of course, my injector is not fully seated in. Now, the next step of this is using a specialty tool here. So I'm going to go ahead and disconnect it. So you work this by pulling up this green clip. It's called a PAC, a positive assurance clip, and then there's a gray tab in the middle. You press with your thumb. You basically squeeze with your pointer and your thumb and pull up at the same time, which can be a little tricky on new harnesses. Okay, and now we can see our 2 pins here for our connections. Now this device here is called a Noid light, okay? And we have this as a service tool, and I will get you its part number here momentarily, but how this thing works is the fact that it sits in between the 2 terminals, and it basically is a blinky light bulb. It's got similar resistance to the injector, but it basically gives us a visual indication that everything is there and working. Its part number is 19623. Again, it's part number 19623. So all you do is you place it in between the 2 terminals here, and it sits there like so. So when I run the system here, I should be able to see the light bulb blink. As you can tell, it seems to be working. And as I run it faster, it also blinks faster. Okay? So the whole premise of what we're doing here is confirming our circuitry is in good shape here. So that proved to us we had the 12 volt battery power there, as well as our signal wire, which was the blue wire with the black stripe going all the way back to the ECM, is intact. The injector driver inside of the ECM must be working because it's commanding this thing to complete a circuit, or basically it's completing a circuit, and this is showing us the evidence of that. Okay, you can test the fuel injector next. Really all you end up doing here is a resistance test on it. So I'm going to take my voltmeter, I'm going to move it to resistance. And all I do is I take my meter leads, and I go in here, I'll pull the meter over here so we can see. And I do a resistance check. Now we need to let this sit here for a moment, catch up. Oops, bump the wires off. It's a tricky one here because the pins are pretty narrow. Let it count up here. These electronic meters take a moment to register. You got to give them a second. So I'm about 12.5 ohms. All right, that's completely within spec. So that would tell us our injector is providing enough resistance that we are happy with that. Now, really and truly, we proved everything seems to be working here with this system. Again, if you have this code, basically it's telling you, hey, I don't recognize that the injector's plugged in right now, is really what it means. So you truly have some sort of circuit resistance issue, and it's usually not enough, all right, to trigger that code. Now, if you don't have the code but the injector is not firing, again, it could be the fact that we have the signal wire is broken somewhere in between here. As far as the ECM knows, it sent the ground signal through that white wire with a black stripe. Everything was sufficient on its end, as well as it sent 12-volt power out. It's satisfied. It won't set a code. Now, however, if that signal wire is broken somewhere, it will set a code, though. Okay, so you need to be cognizant of that. But if it's physically all is there is working, you don't have the code, and it's not firing, there's something internally wrong with the fuel injector itself at that point. All right, so that's the longhand method here for testing this. So next thing we want to jump into is how to look at this with the laptop software. Now, before I do that, I want to explain one theory of operation here that I forgot to do before. When this system defaults, okay, it goes into limp mode, what ends up happening here is that it will basically obviously run in one cylinder. It will continue to allow to have spark on one side of the engine yet, okay? Granted, there's no fuel going through it. It will physically kill the command to the one side. Spark will continue to happen here. Now, the inverse happens, and we'll touch on this at a later program, is that when the ignition coil fails, the system is smart enough that it shuts down the connected injector to that cylinder so that we don't wash the cylinder down accidentally. Okay, so we're going to look at the laptop software next here. All right, so what we end up having to look at here really is a couple of different things. Now we can look at, I just moved to main 2 up here on the tab where we have our different gauge packages here, and I'm looking at an injector open in one time, so I'm going to go ahead and run the board. Within a moment here, it should begin to work. There we go. You can see that it's commanding injector open one time. Now, I just pulled the connector off. You see it went to 0 there, okay? I'm looking at right over in this region here. The other side is at 13.8 milliseconds, giving a whole bunch of fuel. This side dropped to 0. Now, I can even go ahead and plug it back in again. Until I shut the engine off and reset it, it's not going to turn that injector back on. Now, the way to confirm this, I have several codes in here currently, but if I go up here and hit current, or look at historical, oops. Okay, because I have it plugged back in again. All right, so looking at historical here, I have my P201 injector A fault here, okay, or injector 1 fault. All right, so again, that's basically where you're going to look for the code. Because I had it plugged back in again, it was not reading in current. But again, looking out here under main 2 on the dashboard screen, you will see your injector open time. It's commanded that cylinder off at that point. It's no longer sending a pulse. Okay? All right, so it's a summary here again. That's pretty much the same. It goes for each injector. You troubleshoot them exactly the same way. The best course of action is to get the 19623 Noid light, which basically is a real quick down and dirty indicator. You plug it in, and it will tell you yes or no whether your circuit is there and intact and working. Okay, if it doesn't, if all else fails, again, last case scenario, there's a device inside the ECM called an injector driver, and it's a device that's in charge of managing the pulse width modulation of the fuel injectors themselves. So not always can you troubleshoot that. It's really, if you have no signal coming out of here and you're ensured that the wiring between this black connector and here is good, then that is the absolute last step. You'd end up looking at a replacement ECM at that point. All right, so that concludes the P0201 and P0202 codes.